Hi there, Harry from Good Data here. Today I'll be taking you through a recap of our recent webinar, introducing analytics as code and the Good Data VS Code extension. We'll be discussing what analytics as code is and the benefits it brings. There'll be a brief demo to illustrate Good Data's as code approach, specifically with the VS Code extension. But let's begin with some background on analytics as code and how it came about. A number of years ago, engineers used to deploy everything on hardware servers. To run the code, they required like physical servers to do so. But in the mid 2000s, services like AWS and later Azure and Google Cloud began to appear. Brilliant news for engineers because they no longer had to handle hardware. Of course, this brought some other issues about. For example, it was quite hard to maintain a large number of microservices, as you need to deploy a new version of your software, make sure the operation system is up to date, and so forth. And that's how, by the end of the 2000s, infrastructure as a code came to be. Put simply, infrastructure as a code meant that instead of some admin sitting in a dark room next to the terminal and entering commands, there was a repository containing a file that had declarative definitions of what should be deployed and where, and the kind of version you want to use, and so on. Basically, analytics were now being described in a form that a machine could understand, and the machine could then process this and deploy your system. This approach came with a lot of benefits. You could version your infrastructure, you could deploy it to new servers very quickly, and there was very little chance of human error. From there, the approach continued to develop with an increasing number of tools becoming as code. For example, pipelines as code, where rather than manually specifying what and where to deploy each time, static declarative files are defined. Security as code also popped up, and over time, pretty much every aspect of modern tech companies, if you will, began to become codified. And that brings us to the 2020s and the arrival of analytics as code. To effectively discuss this moment in history, it's important to mention another important milestone from around that time, that being the rise of analytics engineers. Who are analytics engineers, you ask? Well, put simply, one, they're responsible for enabling end-user self-service. Two, they spend time with data, meaning they transform, test, and deploy it. And three, they try to apply software engineering best practices to the world of analytics and data. And that last point is super important. The term software engineering best practices is a little blurry. So let's take a look at what these best practices actually are, and how analytics as code helps to bring them into the world of analytics. The first best practice is the ability to create and maintain a solution in an end-to-end manner. This is something that software engineers have been playing with for quite a long time. They have their projects, their workspaces, and all the important aspects of the application or solution in one place. This means they can make any changes there, recover from any hiccups, and so forth. The second aspect is the ability to reduce context switching. So if you have everything in one place, then you'll likely reduce the need to context switch because you can control or maintain the application with one tool. When it comes to analytics applications, this might be an IDE, and for example, in the case of Good Data, the VS Code extension, which we'll be showing you a little later on. The third aspect is validating results and automating testing. Test automation is basically a way to automatically verify the new version of your project, the one that you're going to deploy in a production service to your users, and that you're not breaking anything for the users. There's been test automation in software engineering for a long time. You've probably heard people talking about unit tests, end-to-end tests, functional tests, and the like. This is what allows you to press the deploy button on a Friday evening without worrying that someone might call you up in the weekend and tell you to fix a bug that has been deployed. Another aspect is version control. A lot of tools in the analytical space have some sort of version control, i.e. you can revert to the previous version of your workspace or your analytics project. But with software engineering best practices, it goes a little bit further than that. It's not only about the ability to revert back to the previous version of the project, but you can also branch out. For example, you might want several analytics engineers to work on different features in the same project. They can create different branches in Git and work on these, define slightly different parts of the project, and then link it back to the main branch when the feature is ready. And the fifth aspect is collaboration, which is closely connected to the version control and branching that I just mentioned, as well as Git or other version control systems that are usually cloud services, which have some UI and allow you to interact with that code and those branches. You've probably heard of GitHub, Bitbucket. There are more on Azure too. The important part here is that it's not just you as an analytics engineer who is writing these code files. It's not just you and your test automation. You can make a pull request from one branch to another and ask your colleague to review it, and then you can comment on each line of the code and tell you, for example, this statement looks a bit fishy to me, let's use a different syntax here, or let's use a different metric in this visualization, for example. Not only does this improve communication, but it also provides another layer of security on top of automation tests. This is important because automation tests can cover some basic logic, but when it comes to business logic, a human needs to look into that. Maybe in a few years, ChatGPT will be smart enough, but we're not quite there yet. And the final aspect is iterations. Software engineers have used iteration for a long time as part of their kind of development best practices. As today's world of analytics is all about fast delivery, we iterate to improve visualizations and dashboards and add new information on them. Why analytics as code? Well, now we understand the history of the as code approach and how it incorporates best software engineering practices. Let's look at how the Good Data Platform works with as code analytics. First, here it's important to mention that the platform provides analytics for all kinds of users, not only technical ones who know how to code. We provide everything from kind of drag and drop right through to pure coding, so kind of like the no code, the low code, and the all code areas. For business consumers, there's interactive dashboards and ad hoc analytics. For analysts, there's the point and click UI throughout the experience, for example, to create dashboards and visualizations. And there's also a metric editor and model editor as well. Of course, analytics engineers can also use the point and click UI, but they'll probably be more interested in the fact that we're an API first platform. We have SDKs such as our Python SDK and React SDK, and of course, Good Data for VS Code. To understand more about how Good Data uses analytics, let's talk a little bit about the current state of analytics as code. You probably recognize some of the icons on this slide because since 2020, when dbt began to become a bigger thing, more and more people began to look into the analytics as code approach. Typically, extract and load used custom Python script or some other language. Now you have tools like Meltano that help a little with that, providing a framework to build up your extract and load. Then you can use something like dbt for transformation. Again, everything is as code. You have your SQL queries or maybe Python files to work with for the data transformation. It has been possible to codify dashboards and visualizations for a long time. You probably know HighCharts or Chart.js. There are a lot of libraries for front-end engineers, for example, React frameworks and so on, that are able to visualize the data and you define those as code. However, there's been very little in terms of the semantic layer and metric creation in the analytics section of the pipeline between extracting data and showing it to your users. So that's what we've been trying to do at Good Data, to kind of bridge bridge that gap. This is not our first analytics as code tool. We have declarative REST API. We have Python SDK for things like lifecycle management. We have React SDK that will help you embed analytics through visualizations and dashboards. And finally, now we have good data for VS Code to stick it all together. The way this works is that you have simple YAML files that are declarative and very easy to read and understand. You don't need programming knowledge or to know Python for that. And through YAML, you can define the semantic layer, metrics, and even visualizations and dashboards. Of course, you can still do this in the UI, and you can still use React for that, but it's also possible with good data for VS Code. And that brings us to the VS Code demo time. For the purposes of this, we prepared an analytics as code workspace view. In this example, our semantic model is about James Bond movies and contains just these 3 data sets. There are also 2 dashboards. The first is focused on the actors who played Bond, from George Lazenby up to Roger Moore. As you can see, they're not sorted by time, as the last one was Daniel Craig, of course. The second dashboard is about the movies, so we can filter the movies here, or we can see aggregated statistics about them. How does this look in code? Here we can see the same project cloned to VS Code, Visual Studio Code, and represented as YAML files. On the left side, we can find the files for the 2 dashboards and the 3 data sets. Then we have some metrics created for that, and a lot of the visualizations that are used in these dashboards. As you can see, this is all quite easy to read and roughly corresponds to what you see in the dashboard itself. Our actors dashboard has 2 sections. The first doesn't have a title and just has 1 visualization. And then we have another section with the title and the 2 visualizations. It's a very simple dashboard with just 3 charts on it. The good thing about this as code approach is that it's not just about syntax highlighting. It also helps you to work with the project. For example, if you remove a few characters here, you can see that it's underlined as red. So it basically performs real-time semantic validation of the whole project and tells you, hey, there's no visualization with this idea that you're trying to reference. So there's probably a mistake here. And if you try to deploy it right now, it won't let you. It'll just tell you you're trying to deploy something that's broken. There are also other features. For example, it can suggest the correct answer based on what you've already entered. Here you can see everything that starts with A, and that can be used in that particular context. Let's say you're an analytics engineer and you want to create another visualization on the dashboard. For example, how many years each actor spent playing the James Bond role. You can simply create a new metric and call it something like Bond actors years YAML. For the purpose of this example, let's just copy paste a prepared metric syntax. You can see here, and it says this is a type of metric. It has an ID, title, and MAQL. MAQL, or multi-dimensional analytical query language, is our syntax for defining metrics. It means you can define a metric which can be then sliced by different attributes or different dimensions and so on. Some other companies use templated SQL for this, but MAQL is way more powerful. With MAQL, you have some nested selects that enable you to reach the correct number. Another nice feature of the VS Code extension is that you can preview the metric right away by clicking the Run button. Now you can slice it by certain attributes, for example, the name of the actor. We can see here, for example, that Daniel Craig played Bond for 15 years. Once you have your nice new metric all prepared and tested, you can push it to Git. We're not going to deploy it right away to the server. we'll use some sort of development server to test it out, and then for production, we'll need to create a new branch, name it, and define a message. After this, we can commit and push. So basically, we just saved our changes, put it into GitHub as a new branch and a new variant of this project. And here in GitHub, you can see there are 2 branches now, and there's a new metric branch. It was pushed 19 seconds ago, and GitHub has even suggested a pull request. So now we can make a pull request to our own repository, and it will show exactly what we are changing. We can then ask someone to double check our work using the comment section. Someone might say, this doesn't make sense to me, let's do it a different way. And then we can adjust our code, push a new version, and so on. Once it's past the review stage, we can simply click merge to push our changes we committed into the main branch. And since we have automation set up here as well, it'll automatically deploy this new version to the server. Here there's a script that validates to make sure we haven't made any mistakes, and after that another script deploys it to the server. Now let's return to the visuals again. We have our new metric, and to create a new insight we can use the point and click UI. Here we can now display the number of years the different actors spent playing Bond. Now let's put it on the dashboard. We could of course also change the colors of these bars to match the rest of the dashboard by simply editing the definition. That's a minor detail. The main point we're getting at here is that the source of truth is always the code. It's always there, and we are able to pull and push from and to different servers as we please. And that brings us to the end of the demo. We've shown you how the visual representation you're seeing here can translate as code, and how this is achieved in GoodData. As you can see, we provide the best possible developer experience with auto-completion, IntelliSense, validations, and highly readable code. Plus, the YAML files can be easily collaborated on and easily versioned. During the webinar, we fielded several questions. So to finish this recap off, we've collated the pick of the bunch. So does reporting as code also enable creating interactive reports and reasoning with the data and visualizations through generative AI? In answer to this, it really depends on the analytics solution you're working with. If your analytics solution is purely SQL based, generative API can help you generate the SQL. So you would tell ChatGPT, hey, I have these tables in my database. How do I extract these metrics from it? And it'll probably suggest you some SQL for that. Now, I'm not saying it'll be good, but there'll be something, and you can try and see if it works. And maybe through a few iterations, you get some proper results. In our case, it's even better because GoodData is an analytic solution that's based on the semantic model, semantic layer, meaning that we have a lot of extra metadata on top of the table. And we don't generally use SQL to define the visualization and explore your data. Instead, you're using the semantic model. Generative API can be very powerful with that. We have a few prototypes with OpenAI and ChatGPT, which we can certainly share with you if you like. Does GoodData's analytics as code approach currently cover the entire analytics lifecycle or some parts of it? We cover most of the analytics project using the VS Code extension that we just demoed, which includes some nice features such as autocomplete, real-time validation for most of your analytics project. We also have tools like Python SDK, declarative REST API that can help you with the lifecycle. To explain it in simple terms, you define your analytics workspace, visualizations, metrics, and dashboards as code with the VS Code extension. Someone else asked, what about the ease of deployment of new analytics dashboards to customer environments, especially in the case of on-premise deployments? How does Good Data make this easier? In plain terms, you can have deployment on your own premises. We do provide a cloud-native version of Good Data for that. And that's the easiest way to use our declarative APIs and Python SDK to code your pipelines. So you'll have, let's say, one environment running for your development. You'll create your own analytics there. You'll test it there. And then whenever you're ready, you'll run some pipeline that uses Python SDK and REST API to clone that stuff. And then will actually serve your users from one server to another. Of course, you can also put it into Git in between, so it's completely up to you how you set up your pipelines. Now with Good Data for VS Code, it's even easier because you can define your analytics as code from the very beginning. You don't need to pull something from a server and then push it to another. You define everything in Visual Studio Code, and then you deploy it to, let's say, a development server, then a testing server, and then to the production server in stages, in the same way as you deploy any other application. Now you might use Tableau or Power BI for all those deployments, but can you really do it at scale? I mean, with Tableau, you would probably change the target of your deployment each time you worked with it, or maybe download the assets from Tableau in some kind of zip file. The same goes for Power BI. Doing any kind of customization before you deploy it to the next domain is also kind of almost impossible with those zip files. So you're forced to make all of the changes in the UI each time. Again, it's really difficult to scale that up. Whereas with Good Data, it's all readable. It's designed in a way that allows you to download assets. In our case, the project definition or workspace definition, and do the updates and then deploy at scale using Python SDK or our command line interface. That's it for the webinar recap and the questions from the webinar. Thanks for watching. If you're interested in learning more, check out our website. You'll find further information about Good Data Platform, as well as a whole load of resources on analytics as code and several other analytics topics. Thanks for watching.